Hello everyone, this is a video on the Y-perm. The Y-perm actually consists of performing two OLL, so I'm going to show you those two. Actually makes it easier to learn. But let's talk about recognition first. This is a Y-perm. This is the only case that kind of looks like you just have one lonely guy right here. Nothing else looks anything like that. So, and we can tell a lot just by seeing this. These corners are in. This one's not, so this one can't be. It cannot be. So we're going to swap these. And these two are in, and you can never just swap two corners. So these two have to be out. And that's what it's going to solve. It's going to swap. It's going to move these corners. And it's going to move these edges. If you look at the other two sides, it kind of looks like an E-perm. Everything's all mixed up. But this is how you want to hold it, where this guy's in the front right. This OLL is actually the first half of the Y-perm, and this is the second half of the Y-perm. So I'm going to cover those first. So if you ever see a bar and a dot here, you hold it like this, and then we want to look for a bar and a bar. There's another one that looks the same on top, but these are dots. It's a different case. But for this one, I'll show you this, how you perform this one. It's F, R, U prime, R prime, U prime, R, U, R prime, F prime. And that'll solve it. That's the first half of the Y-perm. So if you get this guy in the front, F, R, U prime, R prime, U prime, R, U, R prime, F prime, we get a T, which is this OLL. There's two T's. One of them's like this, where you don't have a bar. You have like a dot here and a dot here. This is actually the easiest case. It's a sexy move with an F setup move. But this case, where you have the bar, what this is we're going to pull out this F2L pair with a sexy move, and then we're going to sledgehammer it in, because that'll change edge orientation. It'll flip two edges in the top layer. A lot of people use that knowledge for partial edge control when they're inserting their last F2L pair in, so they don't have a dot case. So again, we're just going to pull this out, R, U, R prime, U prime, and then sledgehammer it in, which is R prime, F, R, F prime. And that's the second half of the T-perm. Sorry, Y-perm, and this is a T-perm. I don't know why it's there. Let's see. Okay, so here we go. We do the first OLL, F, R, U prime, R prime, U prime, R, U, R prime, F prime, and then it gives us the T OLL. So we perform the T OLL algorithm and it'll be solved. R, U, R prime, U prime, pull out that F2L pair, sledgehammer it in, it's solved. R, U, R prime, F, R, F prime. Anytime you're doing F moves to insert an F2L pair, you're gonna swap edges, F or B moves. If you're not cube rotating or doing F or B moves, you won't change edge orientation. Another thing that's kind of interesting about this is if you perform on a soft cube, if you perform the T1, pull it out and reinsert with a sledgehammer, you get that first case. And you solve that, you actually get a T-perm. So it's like kind of like a backwards Y-perm, not really backwards, but the first OLL and the second OLL that the Y-perm is. If you switch them, you get a T-perm. So it's another way to perform a T-perm. but it's not as good as performing the T perm the conventional way. So that's it. One more time. F, R prime, R, U prime, R prime, U prime, R, U, R prime, F prime. We got this OLL, R, U, R prime, U prime, R prime, F, R, F prime. We got our T perm, Y perm, sorry. All right, we just got one more left, the Z perm.